We're all really pleased to have such a distinguished and accomplished speaker this year. Dr. Chris Field is the founding director of the Department of Global Ecology at the Carnegie Institution for Science, and he's the Melvin and Joan Lane Professor for Interdisciplinary Environmental Studies at Stanford University. From 2008 through 2015, he served as a co-chair of the IPCC's Working Group 2, which led to the effort on the IPCC Special Report on managing the risk of extreme events and disasters to advance climate change adaptation. He also contributed to the IPCC's 5th assessment report on impacts, adaptation, and vulnerability in 2014. Chris's research emphasizes field and lab-scale studies of the impacts of climate change, ranging from molecular to the global scale. His work has helped improve climate models, examine prospects for renewable energy systems, and study the role of community organizations in minimizing the risk of the tragedy of the commons. He's been elected into many learned societies, including the U.S. National Academy of Sciences, and has been recognized with several national awards, including the Max Planck Research Award and the Roger Revelle Medal. Chris received his PhD from Stanford in 1981 and has been at the Carnegie Institution for Science since 1984. Please join me in welcoming Chris for this lecture on climate change, the road to Paris.
I was fumbling to find the switch to turn on the microphone. You guys have a complicated technology interface here, I got to admit. It's a real thrill to be able to present a lecture named for Dave Keeling, true pioneer who went out in the field and made measurements that nobody thought were going to work. The people who did think they were going to work didn't think they were going to be meaningful. And it didn't take very long before the measurements that he made with tremendous care and precision really turned out to change the world. I think that if we think about 3 phases of the climate challenge, first phase is really awareness, and Keeling's work was fundamental in getting us going on that. And the second phase is really understanding, and I'll talk about the current understanding based on the assessments, especially of the Intergovernmental Panel on Climate Change. And the third component is really solutions, and that's where I want to get to today. And I think that the exciting consequence of coming together for the Paris Accords at the end of last year, that the pathways to solutions are really increasingly clear. They're not nailed down, but the pathways are increasingly clear. Professor Khanna, you didn't end up with my remote control, did you? No. My remote control, oh, there it is. My apologies. So what I'd like to do today is 2 main things. I'd like to summarize the most recent reports from the Intergovernmental Panel on Climate Change, really a unique partnership between the world scientific community and the governments that provides a definitive statement of what we know and what we don't know about climate science. But the most recent IPCC reports are from 2013 and 2014, and they're staggeringly out of date as a result of dramatic progress that we've made in understanding the issues in just the last couple of years. And one of the great benefits of no longer being within the IPCC is I can tell you something that you might think of as IPCC plus. Inside the IPCC, we're really bound by the idea that each new piece of information has to be carefully assessed before it can be presented to the public. Outside, I can tell you what's changed and what the implications are. And I want to talk about 8 things where the world has really changed since the most recent IPCC reports. The first is that when the IPCC reports were released, we really were unclear on whether warming was continuing. And since then, it's totally clear that this concept of climate change hiatus was just a red herring. A second factor is that for decades, we have seen this just profoundly strong relationship between per capita GDP and CO2 emissions. That's beginning to change, and I want to talk about why that is. In the IPCC reports, we talked a lot about extreme events and trends worldwide in extreme events, but we were just at the early stages of being able to do attribution of a climate change component to single extremes. It makes a big difference in the way you think about the implications and in the way you think about the communication aspects of climate challenge. When we try and look at economy-wide impacts, especially using macroeconomic techniques, super difficult to get compelling assessment of what we know and what we don't know. And there were a couple of technical, I would say, well, I'll call them errors that early scholars in this area made that have been resolved and have provided a new window on the magnitude of the sensitivity of the global economy in a spatially resolved way to climate shocks. A fifth factor that's really changed dramatically is a deeper understanding of the instability of the major ice sheets, especially the Antarctic ice sheet. And there's been a lot in the news recently. It's important enough that it's worth talking about for a couple of minutes. I want to finish with two reasons that sort of transition us from the understanding world to the world of solutions. And the first concerns co-benefits. You know, we have tended to think about investments in climate change as requiring pulling resources from something else we wanted to accomplish as a society and putting them over to climate change. But now we see an increasingly broad range of sectors where investments in climate change can satisfy multiple objectives, including important development objectives. So that's the first key to solutions. And then a second key area of solutions that just changed really, really recently concerns the fact that we now have a vision of how to build a 100% renewable energy system. That doesn't mean that all the pieces are in place or that we have the economics down, but at least we can see a technical vision of what a 100% renewable energy system would look like. And that wasn't true a couple of years ago. And then the final factor that's important is really important, and it's the fact that we have the Paris Accords. A lot of people have complained that the Paris Agreement is wimpy or weak or has important components that aren't binding. And the case I want to make, and we'll analyze the implications of the Accord, is that it's an amazing accomplishment to have every nation in the world agree that climate is a challenge that warrants global attention, it warrants combined efforts from every nation on Earth, and it warrants the priority to use the Accords as a starting point for progress in the future. Those are all fundamentally important, and they're fundamentally important enough to change the world. Let me talk now about the frame that I want to use for communicating the issue of climate change. So from my perspective, the climate challenge is really a challenge in understanding, managing, and reducing risks. There are a number of reasons that this is important that I want to go into, but I want to say that one of the failures that I've encountered personally and that we've encountered in the IPCC is the difficulty of communicating this frame. If you look at the media coverage about climate change, typically what you see are stories of doom and gloom, how difficult the problems are. You know, you could characterize this as that the dominant media frame is climate change is a problem such that you should bend over and kiss your sorry behind goodbye. And it's not that at all. There are a lot of things that can be done that are good investments and smart investments in the near term. Let me talk a little bit about the issue of risk. There are two really important things that you need to understand about risk of a changing climate. The first is that there are lots of processes that combine together to create risk from climate change, and it's not just the dynamics of the physical hazard. In particular, risk emerges from the overlap of three fundamentally different things. There's the physical hazard, the trigger, there's the vulnerability or the lack of preparedness of the people and the ecosystems who are in harm's way, and there's the exposure, just the amount of assets that are in harm's way. Society has a tremendous amount of control on vulnerability and exposure now, and we have control on the amount of hazard that occurs through our actions that determine the amount of climate change that occurs. There are at least 5 reasons that this risk framing is fundamentally important. And when I talk about a risk framing, it's understanding that we're conceptualizing risk as a product of the probability of some event occurring and its consequences. A high probability, medium consequence outcome can have a high risk, but so can a low probability, high consequence outcome. And when we look at the range of risks we consider, we want to make sure we look at the full range of possibilities. So why is it useful to think in terms of risk? The first reason is that this risk frame connects the climate changes we'll experience in the future with changes we've already experienced, and we know we face massive losses from weather and climate events now. Second, we know that most climate damages occur in extremes, and even though we tend to characterize climate change in terms of incremental adjustments in temperature, slow changes in precipitation, the real damages occur in the extremes. And so we're talking about shifting a distribution that has average events, but it also has extreme events. And unless we think about those extremes, we won't have an accurate accounting of the risks. The third motivation, it's really important to think about climate as a challenge in managing risk, is that we want to look at the full range of possible outcomes. So one of the things that you'll see in the material I present tonight is there's still a lot of uncertainty in the magnitude and timing of a wide range of impacts, and we want to be prepared if the actual realization is right in the center of the current range of uncertainty, but we also want to be prepared if it's at the extreme high end or the extreme low end. A fourth motivation for thinking of climate change as a challenge in managing risk is that we know increasingly that we're working in a multi-stressor world, and that the threats to societies around the world have climate-related components, but they have land use-related components, they have conflict-related components, they have governance-related components, infrastructure-related components. All these things act together, and you can't solve the problem, you can't even understand the problem if you just look at the components individually. And then fifth, it's really important to recognize that managing risk is something that individuals, corporations, and governments do every day, and we have a wide range of sophisticated and powerful tools that can be applied now to manage risks. And it's not like we need to invent some entirely new paradigm in order to manage the risks of climate change. Okay, with that as background, let me say a few words about where we are. The trajectory of global temperatures over the last century and a bit, and the picture is really compelling. It's terrifying in many ways. 2015 was the first year in the global record where the global average temperature was more than 1°C above pre-industrial. And as we talk about Paris Accords, we'll talk about trying to stabilize at targets of 1.5 to 2°C. So we're already a long part of the way toward the target where the world's governments have decided we begin to face unacceptable impacts. It's also worth looking at the last decade plus. And if you look at the period from 1998 to 2012, that's the period when I was basically leading the IPCC effort, and it was frustrating that there seems to be some cosmic alignment of the stars such that that was a period during which warming wasn't really very obvious. And when you look at the trajectory that's got the most recent couple of years, it's clear that the actual realization of the temperature trend is a series of steps. Sometimes it goes up, sometimes it goes down. But there really were legitimate questions in this period about whether we had something fundamentally wrong or whether the warming had fundamentally stalled. Before I get to the question of resolving this issue of the hiatus, I want to show the Illinois temperature trend. And here in Illinois, the warming over the last century is just about at the global mean. It's around 2 degrees Fahrenheit, and the kinds of impacts that have played out have been comparable to impacts in other parts of the world. So here's the story with what's been called the hiatus or the pause in global warming. And this is a figure from a new paper by Tom Carlin. It's a very frustrating example of the way the political situation in the US is playing out now. The House Subcommittee on Environment has subpoenaed all of the emails associated with the study, not questioning whether the results are correct or not, but just questioning whether there was a political motivation for the timing of the publication. And if you talk to the authors, they make it clear that they were trying to publish this at the most professional, responsible schedule possible. The pattern here is that the circles are the old analysis. So there was the appearance that the warming rate was higher from 1951 to 2012 than during this period from 1998 to 2012. But when it was reanalyzed, taking account of several very subtle but potentially important factors, what the investigators found is that it turned out that there was no significant difference between the warming rate over the whole period and from 1998 to 2012. And the issues that were addressed were things like correctly accounting for the changes in the technology for measuring ocean temperature, going from thermometers in buckets to engine intakes to autonomous buoys. And an interesting thing that also occurs is that we know the areas that are warming most rapidly are mostly at very high latitudes, and the way you average across those zones makes a big difference. And adding that factor results in the triangles that you can see here. And once you include the changes in the ocean temperature, the changes in the number of stations on land, and this correctly accounting for the rate of warming at high latitudes, you see that, if anything, the rate of warming has actually increased. My colleague at Stanford, Bala Rajaratnam, led a really nice study where they tried to assess whether there was any definition by which you would conclude that there had been a global warming hiatus. And the conclusion was there was no framing you could come up with under which the global warming had slowed from the period from 1998 to 2012. So that's really the first point about IPCC Plus that I want to emphasize. Some of you may be aware that there was a recent paper by John Fife and others arguing that, well, in some ways the temperature evolution after 2000 was slow, but their argument is that it's really slow relative to expectations based on the models, not that it was slow based on the historical period. And there are some remaining questions about why we're not seeing an accelerating warming. The next topic I want to turn to concerns what's happening with emissions, and there the pattern is again mixed. In the IPCC report, the conclusion was that emissions of heat-trapping gases are increasing rapidly, and even as world attention has been focused on addressing the climate challenge, what we've seen is an increasing rate of emissions growth. And you can see this looking at the IPCC report, where the emissions growth from 1970 to 2000 was a little more than 1% per year, and from 2000 to 2010 was a little over 2% per year, implying that even as we thought more about the problem, we were making less progress in addressing it. But again, the world has changed dramatically since the IPCC reports, and if you look at the last 2 years of CO2 data, something really important has happened. 2013 and 2014 were years of, it's 2014 and 2015 were years of relatively robust global economic growth, but there were years where the CO2 concentration either increased only slightly from 2013 to 2014, or actually decreased a little bit, our CO2 emissions from 2014 to 2015. And this breaking of the link between economic growth and CO2 emissions, it doesn't say that CO2 emissions have peaked, almost certainly not, but it says that the strength of the relationship is not nearly as strong as we've thought. I would say that that opens a door to the applications of compelling solutions, and that's the second way in which the world has changed since the IPCC reports came out. Let me talk a little bit about impacts. A conclusion from the IPCC report is that observed impacts are widespread and consequential. There's really a sea change in the IPCC reports. Earlier IPCC reports had concluded that we're likely to see important changes in the future, but the evidence that changes are already occurring and that they're already impacting communities, countries around the world really creates a different landscape. In the Working Group 2 report that I co-led, we thought a lot about presenting the impacts that have already occurred in a graphical way. And the icons on this map illustrate that. And you can see icons for different kinds of impacts that have been observed in different continents. The symbols are closed where there's been attribution of a major role of climate change, or open where there's been a minor role. And there's a number of bars that look like a cell phone signal strength that indicates our confidence in the finding. And in some ways, I think of this confidence level as like a plaintive call from the climate science community as can you hear me now? And the evidence is really overwhelming that we've seen impacts to physical, biological, and human systems on every continent in the ocean. We've seen impacts from the equators to the poles and from the mountains to the sea. Here's a zoom in on North America and the kinds of climate impacts that have already been attributed with some level of confidence. And their impacts on snow and ice, on river flow. There are impacts on forestry and forest fires. There are impacts on fisheries, and there are impacts on some aspects of the human system, especially related to trends in crop yields. And essentially, everywhere you look, you're seeing impacts that have a real influence on societies already. And it's interesting when we think about this and go back to the UN Framework Convention on Climate Change, which has as its objective preventing dangerous anthropogenic interference with the climate system. What we can say is that we're already seeing consequential interference with the climate system, and for some people, the people who've lost their home or lost their business as a consequence of a climate change impact, that's already been dangerous. And so we need to think about definitions moving forward. In order to set the stage for understanding where we are with these impacts, it's important to look at the issue of vulnerability. And we tend to think about vulnerability as the most serious problem in communities that lack resources, where poverty, inequality, weak institutions, poor governance combine together to create a trap that makes it really difficult for people to cope with anything. And those create some of the most compelling challenges. But one of the things we've learned in the last few years is that rich societies can be vulnerable as well. And there's a photograph of New York City following Hurricane Sandy, and we had in the Northeast corridor something like $60 billion of damage from an unusual but not particularly gigantic storm that illustrates the vulnerability, especially the financial vulnerability, even in a rich society. I think that if you look across responses to extreme events, what you see is that extremes play out in rich countries in terms of economic losses, and they play out in poor countries in terms of loss of life. And both are tragic, but both are important. Let's talk a little bit about impacts moving forward, and that's the area where we're really beginning to have some important new insights. In the IPCC report, we concluded that increasing magnitudes of warming increase the likelihoods of impacts that are severe, that are irreversible, and that are pervasive. How do you think about that? There are just so many areas where impacts of climate change can unfold. I think the most useful approach is to recognize that we can collect different kinds of impacts in a few baskets that represent different axes of variation along which we can understand them. And primarily these different baskets of impacts reflect the fact that values matter. And from some stakeholder perspectives, economic values that can be represented as global economic growth are most important. In others, it's the equality. In others, it's unique and threatened systems. So what are these categories, and how do they play out? On the left-hand side of this figure, you can see temperature evolution through the century for a world of continued high emissions, the pink plume, and a world of ambitious investments in mitigation. Ambitious investments in mitigation end us up at the 2100 point, at something like 2 C of warming. Continued high emissions are probably more than 4. And if you look across the risk levels for these 4 categories that I'll explain in a little more detail, you can see that ambitious mitigation generally keeps risks in the moderate range, and that continued high emissions puts them in the range of high to very high. And very high is defined as not only is there a a very large risk of severe and pervasive damages, but it's pretty clear that investments in adaptation are no longer relevant, that we've exceeded the boundaries for adaptation, and I think increasingly that's the way we ought to understand where we have the deep responsibility to address climate impacts. Let me zoom in on these 5 burning embers or reasons for concern, and they represent a way to understand the fact that different stakeholders coming from very different perspectives might value the different resources in different ways. The first is impacts on unique and threatened systems, rare species, ecosystems that live on ice sheets, unique archaeological or historical sites. There are lots of these one-offs that you really can't assign an economic value to, and we know we're already seeing impacts on some of these. The second is extreme weather risk. We know that capturing the risk from extremes is very poorly done in the existing economic models, and we also know that that's where much of the damage occurs. So if you're more risk of extreme averse, you put a higher emphasis on this one, or if you only care about the global average, you might put a lower risk. The third one is called distribution of impacts. I think about this as the unfairness factor in climate change. And we know that many of the most serious impacts of climate change impact the communities and individuals with the least capacity to deal with those. And if you care deeply about the equity issues, this is probably the paramount risk. And we know that the risk levels increase very highly for the most vulnerable among us. The fourth burning ember is global aggregate impacts. And we're beginning to see evidence of global aggregate impacts already, and there's been a lot of research on the way those unfold. It's one of the things I want to get back to in a minute, and that's been an important frame, but it hasn't been the only frame that's relevant. And part of the reason it's so important to look across these reasons for concern is to realize that global aggregate economic impacts isn't the only way to see the world. The fifth bar there is large-scale singular events. And that's things like commitment to a very large amount of sea level rise as a consequence of destabilization of a major ice sheet, major loss of biological diversity, sort of one of these one-offs that's existential for a very large fraction of the world's people or ecosystems, where you could think about an economic value for that, but it would be really, really difficult to get convergence on what it might be or should be. Okay, now I'm just going to run through some examples, and most of these are examples about how the world has changed in just the last couple of years. This is a picture of the kinds of extreme events that have been attributed to climate change, or where attributions have been attempted, and it's a wide range of things, going from heat spells to drought, tropical cyclones, mean sea level pressure anomalies, extratropical storms. And the summary now is that there's a wide range of technically sophisticated tools that people are using now to attribute changes in the odds of extremes to climate change. If you look at the outcome of the evaluations to date, the overwhelming majority, something like 95% of the extreme heat events, have at least some signal due to climate change. About half of the heavy precipitation events have a signal due to climate change. So what we're really seeing is the penetration of climate altering the odds of particular extremes that we can analyze in particular places. Many people are starting to ask whether or not this kind of evidence ought to go into, if not policy making, potentially even into legal liability. And one of the outcomes of the Paris Accords was that it did not, at least at the scale of an international agreement. The single event attribution, now a really exciting and increasingly mature science, wasn't really discussed at all in the IPCC report. And this is really the third area where the world has changed. A fourth area where the world has changed concerns the magnitude of the economic impacts. This is a figure from a recent paper by my colleague at Stanford, Marshall Burke and others, that took a macroeconomic approach to the historical relationship between hot periods and economic activity. Now, this macroeconomic approach has been tried before. In general, what the conclusion has been is that there's no strong indication of an overall response. And that's because the investigators tried to fit this with a linear function. What Burke and colleagues said is, well, you know, maybe the response isn't linear, maybe in fact warmer temperatures increase economic activity when the starting point is cold and decrease economic activity when the starting point is warm. I know that sounds like kind of an obvious thing to say, but nobody had really tried it before. And when they fit the data on historic temperature variations and historic economic activity on a country-by-country basis, what they found was a very strong evidence of a single temperature that maximizes economic activity. The temperature was around 55 C. I forgot to look up what the average temperature here is, but it's about the temperature in San Francisco. If you're in a region that's colder than San Francisco, in general, warming is beneficial. And if you're in a region that's hotter than San Francisco already, warming is detrimental. And if you look at the 2100 map at the top, what you can see is that in cool countries, there's evidence of economic benefits from climate change. And if you look at warm countries, there's evidence of economic losses from climate change. And these are presented in terms of percent change in per capita economic activity with some truly profound changes. And if you look at the time evolution for Europe, Southeast Asia, and Sub-Saharan Africa, you can get a sense of the magnitudes. At the global scale, by 2100, this is projected out to be about a 20% loss in per capita GDP as a consequence of the climate changes. And that compares to what most studies had concluded before was likely to be a 2 to 5% loss. So much, much larger when you incorporate this nonlinearity. And what you're doing is combining positive responses for places like Europe and strongly negative responses for Southeast Asia and Sub-Saharan Africa, where you can see these losses are playing out on the order of 100% loss of per capita GDP. So that's the fourth way that the world has really changed since the IPCC report. We really didn't know the magnitude of these responses. And this particular study hasn't gone through an IPCC type assessment, but the indications are that it's likely to be robust. The final impact category I want to talk about concerns these large-scale singular events. And what we've seen unfold in the last couple of years is a dramatic new understanding of the vulnerability of major ocean ice sheets. You know, sea level rise is really driven by three major components. One is thermal expansion of warmer water. The second one is melting of glaciers and loss of water from major water bodies on land, and a third is melting of major ice sheets, especially the Greenland and the Antarctic ice sheet. And the real areas for concern are Greenland and Antarctica, where Greenland has about 8 meters of sea level equivalent, north of 25 feet in the frozen ice, and Antarctica has about 58 meters of sea level equivalent in the frozen ice. And for a long time, there's been a discussion about several modes that could make ice sheets unstable. And in particular with Antarctica, there's been a lot of discussion of what's called the marine ice sheet instability, the idea that once the ice retreats beyond a certain point, there are various physical forces that accelerate the retreat and make it essentially unstoppable even if the warming stops. And this is a result from a recent paper by Ricardo Winkelmann and others, which said, what are the consequences of burning different amounts of fossil fuel for the loss of Antarctic ice after 10,000 years, a very, very long period. And what Winkelmann concluded is that if we don't burn any more fossil fuel, it's likely that Antarctica is relatively stable. If we burn about 500 billion tons more, which is enough to cause about 3 C of warming, we're committed to about 2 to 3 meters of sea level rise. And if we burn 1,000 billion tons of CO2, the figure C here, we're committed to something that's approaching a 10-meter sea level rise as a consequence of almost complete loss of ice from West Antarctica, this region here. One of the most concerning things I've seen in the last few years is a whole bunch of papers that have looked at the dynamics of particular parts of the West Antarctic ice sheet, particularly the Pine Island Glacier and the Thwaites Glacier, which are right about here. And there's really good evidence that they've already passed this point of dynamic instability, and we may be looking at commitment to loss of those 2 ice sheets, which could erode back into about 3 meters, so sea level equivalent, even with no further warming. Now, when we talk about the motivation for a 1.5 versus a 2C target, it's worth keeping in mind that this amount of sea level rise, 3 meters approximately, may already be committed over something like a 1,000-year time scale. But what is that time scale? So this is the 5th way in which the world has changed. And let's look at what the time scale might be. There's a paper in Nature just last week by DeConto and Pollard that really did a beautiful job of characterizing not only this marine ice sheet instability that has to do with the physics of the way the bottom of the ice works, but a new kind of instability that looks really compellingly analyzed called marine ice cliff instability that has to do with the strength of very tall cliffs of ice. And what they concluded is that with high levels of warming, continued high emissions, we might be looking at the contribution from Antarctica of something like a meter with a possible high range of 1.3 meters over the 21st century. That's a substantial, a several-fold increase greater than the IPCC report. But interestingly enough, it also shows the commitment to large amounts of ice sheet loss over long periods of time. And here's the same result through 2500. And you can see that in the world of continued high emissions, we're now looking at something like really, really big number, right? 15.65 meters of sea level rise by 2500. The compelling and I think amazingly powerful good news from this study is that in a world of ambitious mitigation, a world where warming is limited to something like 2C, we see almost no long-term sea level rise, only 1/4 of a meter over the next several centuries. Okay, let me begin to transition now to talking about solutions. And one of the most important things to remember about solutions is that we know now that the warming caused by CO2 is essentially permanent, at least on a multi-century time scale. You can think about the world having a carbon budget, and we know that we hit 2C of warming at something like 3 billion tons of CO2 emitted to the atmosphere by fossil fuel combustion as a consequence from the beginning of when we start emitting CO2 until we hit the 2C. We've emitted about 2,000 billion tons so far, so we're about 2/3 of the way there. Another way to see this played out in slightly more technical terms is this relationship between the long-term warming and the cumulative anthropogenic CO2 emissions. And what you can see is that 2C warming is associated with emissions that, depending on the level of confidence you want, might range from around 2,500 billion tons to about 3,000 billion tons. Well, a really interesting, I don't know whether to call it just a nuance or a trick that's coming from the climate science community is often people are talking about the requirements for having a 66% confidence of staying below 2. But there's no engineering problem where we'd say, oh yeah, I'm comfortable with a 66% probability that bridge doesn't fall down when I drive across it. And I've made the uncertainty band here quite wide and extending all the way out to the very edge of the range of model outcomes, because I think it's quite likely that if the world addresses this in a serious way, they're going to say we want a 99% probability of not exceeding the threshold that we pick. Okay, so how does this play out in terms of a trajectory for emissions? In a world of continued high emissions, where we end the century with warming of something like 4C, at a time when we're still increasing the temperature by something like 0.3 C per decade. So essentially, this is not a 4C scenario. This is a blow-through 4C scenario. We would end the century with something like 100 billion tons of CO2 per year. And if we want to limit warming to 3 or even to 2, what we're really talking about is bringing CO2 emissions to 0. That's the inescapable consequence, the inescapable implication of this carbon budget framing. We know now that there is no way that we can continue emissions into the indefinite future and stabilize warming at all. because the effects of the CO2 warming last essentially indefinitely. One of the striking features of this 2C trajectory is having profound implications on the way we think about the problem. And it has to do with the fact that if you look at this trajectory, it shows rapid decreases in emission that are accelerating through time and that are getting us down to zero emissions late in the century and probably below zero by the time we're at 2100. We would have to fully decarbonize industry, transportation, buildings, agriculture by 2100 to stabilize at 2C. It's a big challenge, and it's a particularly big challenge when you start thinking about this emissions going below zero, essentially removing CO2 from the atmosphere and putting it in some kind of permanent storage. In the IPCC, that's often called biomass energy with carbon capture and storage, and whether or not it works is, well, I like to think about it as waving a magic wand, and there's essentially zero evidence that that's something we could do, and there's especially zero evidence that it's something we could do at scale. So I want to spend the last few minutes talking about solutions, and let me begin to paint a picture of what we might think of as the solution space in a changing climate. So there really are a lot of things that are beginning to happen, and I know this talk has been kind of doom and gloomy about how much worse things look than we thought they looked a few years ago, but I really want to shift gears because in many ways they also look better than we thought they looked just a couple of years ago. So the first thing I want to start with is this emphasis on climate as a challenge and managing risks. We know how to manage risks. We do it all the time in military security, we do it all the time in business, and we do it all the time as individuals when we do things like purchase a car with anti-lock brakes or airbags. Second, it's also clear that the components of the solution are really beginning to be implemented. We're really seeing real investments in adaptation. Some are big-scale engineering things like this flood barrier in the Rotterdam Harbor, but others are community-scale investments like planting mangroves in order to protect coastal habitats. We also are seeing lots of evidence that that investments in renewable energy and mitigation are building momentum. I think everybody's aware that in the US we saw more deployment of new wind and solar last year than of any kind of fossil energy. And so what we're really seeing is experimenting, learning by doing, building an agenda for renewable energy economy. And then finally, I think what we're seeing is probably the most important element of the confidence. We're beginning to see lots and lots of opportunities where investments in adaptation or mitigation don't have to take resources away from the other things we want to accomplish as societies. We're beginning to see opportunities for win-wins between mitigation and development, adaptation and development, or win-win-wins between adaptation and development and mitigation altogether. So how's this work? Let's step back and look at what I think is kind of the core relationship that got us in the fix we are now. And this is the relationship between per capita CO2 emissions going from less than 100 pounds per person per year to more than 10,000 pounds per person per year. And global economic activity ranging from about, less than around $100, $200 per person per year, up to about $50,000 per person per year. And what you see over this full range, at least in log-log space, is a strikingly linear relationship that says if you want to get richer, you need to have more CO2 emissions. And that's the reason that CO2 is the gas that needs to be tackled, especially in combination with this essentially permanent warming. So what we need to do is not figure out how to have less economic activity. What we need to do is figure out how to break the relationship between CO2 emissions and economic activity. And let's see what we can say about that. Where are emissions coming from? Here's the country-by-country plot. I'm sure all of you have seen this. China is, by a large margin, the largest emitter now. The emissions from China in 2015 were larger than the sum from the US and the EU combined. And This figure really highlights the motivation for thinking about the climate challenge as needing to get addressed in all parts of the world, but especially rapidly developing parts like China and India. But it's not just a problem of the big emitters, and that comes into focus when we look at emissions per capita. Here's the per capita emissions, and what you can see is that it is the case that China is now a little more than the world average, but only a little more than the world average. And the big emitters on a per capita basis still tend to be countries in the developed world, especially the United States, which is more than 3 times the global average still. But it's impressive how much state-to-state variation there is in that. And here's the same picture on a state-by-state basis showing the U.S. average. Illinois is just about at the average. I came from Wyoming, and this is not my fault, but what you can see is that there are just dramatic differences in state-to-state energy systems, extent to which states are involved in exporting energy versus not, and climate consequences as well. Now I'm based in California, where a lot of the reasons the emissions are low is because we have progressive climate policies, but a lot of the reason they're low is just a consequence of the favorable climate. So how are we going to deal with this, and what's it going to cost? In the IPCC took a glass half empty perspective on what it's going to cost, and this is the IPCC perspective. The conclusion is that there are massive inflows of investments required in several areas, and according to this analysis, we need north of $300 billion a year in energy efficiency. We need north of $100 billion a year in electricity generation, almost the same amount in renewables, some in nuclear, some in power plants with carbon capture and storage. And there are really only 2 categories where we need less investment, and that's extraction of fossil fuels and construction of fossil-based power plants that don't use carbon capture and storage. Now I look at this and I see a glass half full, saying there are opportunities for building great companies in a whole bunch of areas, and particularly in the area of energy efficiency, which is especially attractive because those are the kinds of investments that tend to save money at the same time that they save CO2 emissions. But certainly there are opportunities for tremendous growth in electricity generation, renewables, power plants with CCS, and potentially nuclear. We can talk about the nuclear issue later. So where are we and how are we going to address it? Here's a distribution of the U.S. electricity production 2015. And what you can see is that non-emitting sources are responsible for just about a third of the total. In fact, one of the kind of interesting features of where we are now is that coal, gas, and all renewables together each constitute about a third of U.S. energy electricity production. Of course, this doesn't account for transportation and industries, which are mostly fossil-based at all, making the U.S. end up about 85% fossil. The kind of scary feature of this is that wind and solar don't constitute a very large fraction. They constitute, wind's about 4.7% and solar's about 0.6%. Really dramatic how rapidly wind and solar have grown. Since the 2006, the solar increased more than 20-fold, and wind increased something like 6-fold. So dramatic growth. And the question is, what are the enablers going to be that allow that growth to continue? So the first issue to look at is the cost, and the IPCC really got the cost wrong in some important ways. This is a recent study from the National Renewable Energy Laboratory looking at current and 10 years in the future costs for coal, natural gas combined cycle, photovoltaic, and wind. And the striking thing is, let's look at the 2014 numbers. Natural gas combined cycle is substantially cheaper at the low end than coal. Solar is a little bit more expensive, but wind is already cheaper than coal and about the same price as the cheapest gas. And by 2025, the projection is that both solar and wind will be cheap relative to any fossil sources. I view this as tremendously encouraging, and what it really means is that in the right kind of policy environment, we can see very large penetration of these technologies into the energy system, even without anything except getting rid of the subsidies that are currently on fossil. So the challenge then is, could we build an energy system, if these price signals carried through, that would allow us to have stable, reliable energy availability given the concerns about intermittency of wind and solar? And my colleague Mark Jacobson at Stanford published a recent study that carefully looked at that question for the United States. And it started out with this well-known pattern that you get electricity from photovoltaics when the sun shines and get electricity from windmills when the wind blows, and that's far from constant, and it's not very well aligned with the demands of our current economy and energy system. So then what Mark and his colleagues did is they looked at the current status of demand and ways that demand could be shifted with low technology approaches like storing heat and cold as hot and cold water, charging up electric vehicles when the sun shines and stuff like that. So here's what they projected the time course of demand over a 4-day period to be. And the really interesting thing is that if you did this right and you look at the balance between supply and demand, what Mark concluded is that you can get supply and demand to exactly match each other, the dots and the lines in the top figure here, without any fancy storage like large-scale battery storage or anything other than technologies that we have access to now and we know are available. So this constraint, the idea that you couldn't build a reliable energy system because of intermittency, was a real cornerstone of the IPCC report, and at least based on this study, it looks like it's far from correct. So I think this is a sixth way in which the world has changed since the IPCC reports. Okay, what I'd like to do now is switch to this topic of co-benefits, and to do that I'm going to subject you to a little video. I have trouble capturing the level of optimism that I would like to convey, and so this video I hope helps. It's only 1 minute.
There are many ways we can reduce and manage the risks of climate change. There are low regrets options that reduce vulnerability and exposure, such as building safer homes, improving irrigation and drainage, and restoring ecosystems. There are also many tools available for anticipating impacts and reducing risks. Values, goals, and learning are important in responding to climate change. Reducing emissions of heat-trapping gases decreases the amount of climate change that will occur. The Intergovernmental Panel on Climate Change Working Group 2 Fifth Assessment Report assesses a wide variety of approaches for responding to the risks of climate change and building a more sustainable world.
Okay, I wish I could get the music to be a part of my vocal presentation, but I hope that gives you a sense of the range of possibilities. And when we look at co-benefits, there's really a compelling body of information about co-benefits from job creation. You know, there's almost 200,000 jobs in the solar industry in the US now. Certainly profound co-benefits in terms of health, and the estimates are that nearly 100,000 people a year in the US suffer early mortality as a consequence of particulates from coal, several million worldwide. Lots of potential benefits in terms of development, especially where renewables can penetrate into developing regions at a lower capital cost. Lots of possibilities for advances in equity where the renewable resources are much more broadly distributed across the world than the fossil resources. And then finally, there are lots of opportunities for using the climate issue as a way to build stronger communities. So I would argue that this is really the seventh way that the world has changed since the last IPCC reports, that we have an increasingly complete vision of where these co-benefits come from. So finally, I just want to spend a couple minutes talking about what we did and what we didn't do in Paris. The Paris Agreement was really striking in its commitment to an ambitious goal, The goal was to hold warming to, quote, well below 2C, and to pursue efforts to limit the temperature increase to 1.5C. The agreement was really marked by a series of features. The first is that it's universal. Pretty much all countries agreed to do it, 196 countries. It's binding, and in some important ways, it's binding in that all countries need to bring forward INDCs and agree to have their emissions audited. It's not binding in terms of the emission level, but I think that that's beyond what could be expected from a UN-type process. There was a pledge, they're called intended nationally determined contributions, or now they're called nationally determined contributions since they're no longer intended, from every country. There were real commitments to improving international finance and technology sharing as a result of the agreement. And there was especially clearly a role for non-state actors, for private companies and for cities and states to be a part of testing out solutions and seeing what works and what doesn't. In California, I'm really proud of the leadership that the state has taken in deploying ambitious climate targets, learning from those in a way that can be spread around the rest of the world. So what did we get and what didn't we get in Paris? What we actually got in terms of the intended national contribution, the climate pledges, is not all that impressive. The business as usual world is the red band here, with emissions from the present to 2025, increasing gradually, and the consequence of the pledges that were in place in Paris were shifting us down to the yellow. So not a huge change, but at least it's a change in direction. When Christiana Figueres, the Executive Secretary of the UNFCCC, talks about the agreement, she always emphasizes that it's a floor and not a ceiling, and it's really an enabler for commitments that still need to be strengthened. Here's another way to think about this. I already talked about the carbon budget concept and the fact that we've already emitted about 2/3 of the budget for getting to 2C. That 2C warming is out there at what we think is just south of 3,000 billion tons of CO2. If we have 100% compliance with the INDCs for Paris, we're at 542 of that 1,010 by 2025, and by 2030 we're at 748. That means that we would have used up the lifetime forever budget in 12 years after 2025, or in only 7 years after 2030. Obviously, the Paris Accord leave a tremendous amount more that needs to be done, but I hope by showing the way that our understanding of the issue has changed since the last IPCC report, you can see the pathways for strengthening the agreement. I want to close with just one final thought. We face a wide range of societal problems, and climate may be the most important one, it may not, but what we increasingly see is that solving the climate problem is a part of an approach to building a world with robust economies and vibrant communities. And if there's a risk moving forward, there's really only one, and it's a risk that is much better communicated by my favorite cartoonist, Tom Towles, than anyone else I know. And it's the idea that we really don't have any time in order to make progress on this issue. So in this cartoon, we finally have a breakthrough solution for the climate challenge, and since for 2030, and the breakthrough solution is a time machine, because we realized in 2060 that it was in 2010 that we really needed to take concrete action. And so if there's a single message I want to leave you with, it's that the climate challenge is one we can solve, but we don't have time. We need to act on the opportunities that are available now. So thanks very much.
Initiatives that they tackled on renewable energy, do you feel that those initiatives are
So the question is, what do I think about companies that are providing green energy on the grid as an alternative for consumers? Yeah, right. You know, I think that this should be an open marketplace of ideas, and there are many communities and many companies, many universities are committing to purchase 100% renewable energy. And I'm not sure that all of the actors that are out there now have a viable business plan, but I think that in the spirit of learning from different kinds of strategies and making a wide range of approaches available is the way that we'll most quickly figure out which strategies work and which don't.
So what do you think about the feasibility of global carbon price? I have seen some people talking about
Uh-huh. Question is, what do I think of the feasibility of a global carbon price? Politically or in terms of the economic implications? There are lots of reasons that everything I talked about would be dramatically accelerated by having a price on carbon. It's not even 100% clear that it needs to be a global price. In California, we have a price on carbon. It's really beginning to shape the way that the economy works. And I don't know any savvy scholars of the world situation who think that we're close to having a global price on carbon. But we now have a price on carbon. It's way too low in the European Union, the northeastern US, California, several Canadian provinces. Again, we're learning by doing. And there are some very compelling arguments for how a price on carbon could be effective even if it's not deployed at the global scale. And as that philosophy builds traction, there's a strong tendency for additional actors to be drawn in, particularly if a regional carbon price is associated with some kind of a carbon tariff, which might be used to reinforce it. Whether or not we're headed in that direction, I think it's really important that we're seeing experimentation with regional carbon prices. And so far, honestly, the carbon prices, since carbon prices have been put in place, economic growth in the areas that have them has been faster rather than slower. Uh-huh.
Can you talk a little bit more about why we're faced with the CO2 budget? Isn't it naturally removed from the air over time?
Yeah, so the question is, why is there a CO2 budget, and doesn't the fact that eventually 80% of the CO2 ends up in the ocean means that 80% of the warming goes away? And it's a really good question. What turns out to be the case is the process that removes CO2 from the atmosphere also controls the rate at which heat is partitioned into the oceans. And so a significant fraction of the CO2 stays in the atmosphere almost indefinitely, but that's only on the order of about 25%. Most of the reason that the warming from CO2 is essentially permanent has to do with the fact that as the CO2 partitions into the ocean, the ability of the ocean to remove heat from the atmosphere slows down at approximately the same rate.
I have a kind of intuitive question. Can you comment on the role of population growth on climate change? Has IPCC ever considered about the impact of population control on climate change?
Right, so the question is, what about population growth and climate change? And has IPCC worked on the topic of population growth? Actually, I'm planning an assessment now that would not run through the IPCC that would address exactly this issue. And let me just say two things about the scholarship that I'm aware of on population growth and climate change. As a prelude, it's clear that in any way you think about pressure on the Earth system, more people creates more pressure. So there have been some studies that have said, well, what's the benefit cost ratio of investments in the existing need for family planning services relative to other kinds of emission reductions technologies? And it's pretty clear that meeting the current existing demand for family planning is a very cost-effective way to contribute to mitigating climate change. So the economics look favorable, but it's also important to remember that per capita emissions figure that I showed earlier, and a lot of the issue is that there's a small number of people with very, very high emissions, And in the absence of efforts to mitigate, we're going to see a much larger fraction of people move into the level of economic activity where we would expect high emissions. And so population is an important driver, but it's not the only driver. There are lots of reasons to think that in the context of building a better world, that meeting the existing and dynamic demand for family planning services is going to be an important part of that.
What other risk assessments would you say compete with those of scientific studies, whether within the IPCC or other scientific groups, compete with their ability to shape strategies to address climate change and global warming?
So the question is, what other kinds of risk assessment or other kinds of strategic approaches are influencing the decision framing, and in particular, maybe competing with the IPCC mode. And this climate change has obviously been a political hot button issue, and there have been orchestrated efforts to convince the decision makers that it's not a problem. My sense is that the organized opposition to progress on climate change has mostly drifted away. Right now, I think the biggest alternative risk assessment out there is the assessment from many of the actors in the private sector who are saying that they'd rather be engaged in solutions a little bit later rather than a little bit sooner. And it's well known, for example, that the major oil and gas companies all do their internal accounting with a carbon price, but in general they don't embrace the idea of a carbon price for their external activities. Simply transitioning, if the oil and gas companies were to go to Congress and lobby for a carbon price as a part of an income tax reduction, tax simplification, it could be hugely impactful. The other major, I don't know if I would call it a risk management approach, but there's a tremendous amount of inertia in many sectors of the global economy. The utilities are, deeply invested in the cost-income model that they currently use. The construction trades tend to be very, very conservative about deploying energy efficiency measures just as a risk management strategy. So at this point, I'm most concerned about the inertia in the system and less concerned about active opposition to deploying climate solutions.
I read recently that the EPA has been chronically underestimating the methane emissions from the fracking boom. Does that change the equation in terms of decoupling economic growth from greenhouse gases?
Yeah, so the question is, what about methane? There are several greenhouse gases I didn't really talk about, and there are compelling new studies indicating that from about 2000 to 2010, methane releases from the US were more rapid than had been accounted for with the EPA process. And the studies that looked at this said that they couldn't tell what the sources of the methane were, but it was most likely production agriculture, especially animal agriculture, and natural gas production from fracking, leaking from natural gas production. And natural gas, or methane, is an important greenhouse gas. It's much less long-lasting in the atmosphere than CO2. It tends to last about a decade, but over 100 years, the integrated warming potential is many-fold higher than that of CO2, about 25 times. And there's nothing with natural gas that's the strong causative link like we see between economic growth and CO2 emissions historically. The one relationship that actually worries me a great deal is that there is a very strong relationship between per capita GDP and preference for meat-based diets. And meat-based diets are a strong forcer of climate change, not only because of the methane, but also because of nitrous oxide that comes from fertilizer and manure management. And so getting a handle on those is going to be important. Because methane doesn't last as long as CO2 in the atmosphere, I'm less concerned about it than I am about CO2. But I do think that managing methane from natural gas production has to be a top priority. And most of you know that there's been a fracking boom since about 2000, resulted in a huge increase in the fraction of the U.S. electricity that comes from natural gas, a big decrease in the electricity coming from coal. But there have been some calculations that the extra methane leaked to the atmosphere as a consequence of the production technologies that have been used in the oil and gas production sector have actually led to a net climate change from natural gas that's as great as that you would have from coal, even though the per BTU global warming from coal is about twice as large of that as natural gas. While that's true, I think it's also very clear now that the conscientious producers have the ability to produce fracked methane with very little release to the atmosphere. The problem we have is a weak regulatory environment, and that's mostly under the control of the states. And at least for me, the real target for action on natural gas should be strengthening the regulatory environment so that we don't leak it to the atmosphere, rather than saying we wouldn't want to use it in the energy system.
So just as a quick follow-up, does methane leave the atmosphere in a way that does not inhibit the ocean's ability to absorb heat then?
Yeah, so the reason that the warming from methane is less permanent is that methane is destroyed by chemical processes in the atmosphere with a half-life of about 10 years, and it's converted into CO2. So you end up with a residual CO2 effect from methane, but because CO2 is so much less strong as a greenhouse gas absorber, that's a relatively minor component. I can't believe it was that clear or that uncontroversial.
So Chris, what do you think is the likelihood that we would in fact be able to keep to the 2-degree warming target, under this Paris, whatever was achieved in Paris? Is that going to get us there? Or, a lot of people say, well, it's too late to mitigate, we should just be adapting. So.
Well, that's wrong. Because what we know is that if we have a world of continued high emissions, we will have temperatures that are so elevated that we have no clue about whether it's even possible to adapt by the time we get to these very high temperature elevations. The question of where we get with the Paris agreements, I think, is far from clear. If you add up the INDCs and then say the world goes into a lock and goes back to business as usual, it hardly makes a dent in the temperatures in 2100. And if you thought that our only chance to address the climate challenge was whatever happened in Paris in December of 2015, then we're really sunk. I would argue that that's not the right way to think about the Paris agreements, that the Paris agreements need to be understood as creating the kind of predictable environment that's going to be necessary for corporate and government and individual decision makers, stakeholders, in order to make decisions that allow us to ramp down emissions over time. And when I look at the numbers, especially the deployed electricity costs for the renewables, I think it looks like there's going to be an increasingly compelling motivation for transitioning to the renewables. But I also think that without additional incentives that are coming at the scale of governments, that's going to be way slower than is consistent with stabilizing warming at 2°C or less.
It seems in the political sphere that the preferred framing of the issue has been as carbon pollution and a kind of attempts by the Obama administration to pitch climate change as essentially a health issue. And certainly, to what extent do you think this is a real factor in China's uptick in climate mitigation policies and activities? That it's actually healthcare risks and actually a massive increase in risk of urban and rapidly urbanizing populations.
Right, so the question is, why does the Obama administration talk about it as carbon pollution? And is the idea that CO2 is carbon pollution with the possibility of health effects likely to be impactful? And how do you think about it in China, where there are profound daily experience health impacts from air pollution that's not CO2 but is other effluents from fossil fuel combustion? And the answer to those questions is really very different for the US situation and for China. For China, one of the things that I think the Chinese government and society has done a really good job of is recognizing that the air problem has a climate component and an air quality component. And people are immediately deeply concerned about the air quality component, and they're demanding action now. And that many of the decisions about what those actions should be are smarter if they also acknowledge the climate component. So I think that's the philosophy I see unfolding in China, and it will hopefully enable China to, not only make good on its INDC of having emissions peak by 2030, but even do better than that. In the U.S., the reason the Obama administration talks about CO2 as carbon pollution has a lot to do with the regulatory vehicles that we have available to us, which are currently the 1990 Clean Air Act, and in the Supreme Court 2007 EPA versus Massachusetts, there was an endangerment finding that said CO2 can be regulated as a pollutant under the 1990 Clean Air Act. So if we're going to have a clean power plan, it's because that endangerment finding said that CO2 is a pollutant that can be regulated under the Clean Air Act. And that's not to say that there are health impacts of the CO2 as a health-causing agent, although there's some interesting possibilities there that are not fully explored, but because of the climate damages was where the EPA versus Massachusetts legal decision came.
So how come the prospect of having environmental refugees for internally displaced people because of climate change?
You're saying what are the risks of large-scale migration as a result of climate change?
Yeah, what kind of a risk, or is this going to be an issue?
Yeah. So the question is, to what extent is large-scale migration a likely consequence, a risk of a changing climate? I showed you the per capita GDP results from Burke et al. With these massive losses in per capita income in the equatorial countries and substantial gains in the wealthy countries in the high latitudes in the north. I find it really hard to believe that if I were reading that paper, sitting in one of those equatorial countries that was experiencing profound impacts, that there wouldn't be motivations to consider moving. Realistically, migrations are driven by a convergence of a large number of factors. Some of them are environmental, some are political. There may be environmental triggers to some of the political things. And so it's very difficult from the perspective of 2016 to make predictions of what kind of environmental migrations we might see. But the risk is certainly real, and the economic models that say that we shouldn't expect very large impacts of climate change assume large migrations where people follow the economic opportunity and where massive numbers of people relocate into regions where food production, water security, and human health risks are less. Mm-hmm.
Given almost business as usual is not highly probable, but quite probable, what do you believe is the possibility of geoengineering somewhere around 2050?
Uh-huh. So the question is, do I think that the world will deploy a different approach instead of cutting greenhouse forcing by decreasing the amount of greenhouse gases that are emitted, put basically a shade in the atmosphere as using an aerosol or another structure that would reflect radiation. It's called solar radiation management. I think that the most profound issues and the likely most profound costs of solar radiation management aren't going to have anything to do with how much it costs to have the technology to shoot sulfate aerosol into the atmosphere. It's really going to be the governance, the institutions that would be required, the nature of the international agreements that might or might not be in place, the risk perceived by a single actor if one chose to undertake it individually, and the limited knowledge of how that kind of deployment might be managed. To me, all those risks look really big, and I think that they argue against the likelihood of widespread deployment of solar radiation management. On the other hand, if the optimistic scenario about increasing commitments to a sustainable energy system that I've talked about don't come into play, I think it's quite likely that arguments in favor of looking at other alternatives are going to get stronger and stronger and stronger. Which may be another argument for working hard on the mitigation strategies that are available now. I didn't.
What's your opinion on Bjorn Lomborg's smart target initiative towards risk management of climate change?
What's my opinion on Bjorn Lomborg's approach? Well, if I can oversimplify Lomborg's perspective, it's always been that if we make people rich, they'll care enough about climate that eventually they'll do something. And I think that there's certainly something to that, right? We know that in the United States, once incomes hit a certain level, people started investing in protecting the environment. But I also think that this cumulative carbon budget imposes an important new set of constraints. And so while we ought to recognize that people are going to have more and more reason to invest in, let's say, quality of life, that we have a really narrow and rapidly closing pathway to limiting warming to something like 2°C. And I think there's an accumulating body of evidence that warming much above that is going to really result in impacts that the world regards as unacceptable. I guess the other thing I would say is that I think there's an increasing body of evidence pointing to the idea that that the cost of a transition such that we bring emissions to zero somewhere around 2100 are likely to be very small or potentially even nothing. And so the motivation on timing says we should be doing more than just expecting people to decide they care about it based on their own volition. I think there were one or two more hands, but I don't know when we're supposed to quit.
Continue the conversation outside. We've got some beverages and cookies, so please join me in thanking Chris for this.
Thank you. Thanks for great questions.